TypeScript is an incredible language. I owe it for so much of my success. I cannot imagine building for the web without a typed superset of JavaScript. It's just, JavaScript itself is not good enough for the things that we do and the aspirations we have for what we want to build in the web. That said, TypeScript is far from perfect. I bring up issues with it all the time, but I've never went this in depth. Why am I going so in depth? Well, I moved off. No, not me. I'm not moving off TypeScript anytime soon, but I have been seeing people start to make the move, including the engineers over at Motion. They just announced that they are moving off of TypeScript, and I actually think there's a lot of good information here for us to dig into and learn about. What does it look like to bet on TypeScript at these large scales? And more importantly, why would someone consider moving off once they've built into the ecosystem so heavily with a giant team? These guys talk about everything from Turbo for Monorepo to the TypeScript Go rewrite to the performance issues with Zod v3 versus v4. It's really, really good stuff, and I can't wait to dive in and give my thoughts on why someone would move away from TypeScript, because I know, I love it. You probably don't expect this. This is a really good article. That said, if I have to go rewrite all of my code, somebody's got to cover that lost eng time. So quick word from today's sponsor, and then we'll dive right in. Have you ever just spent a whole day working on a big feature, like 10 plus hours of coding? You finally get it all working. You're pumped about what you've done. You put up a pull request, wait for CI to build, and then it just fails. For no seeming reason. The logs don't work. It took forever to build anyways. You can go try again and then wait another 20 minutes to see another obscure failure that doesn't give you any information. Wouldn't it be nice if those builds were way faster? Wouldn't it be nice if those builds had actual analytics and observability? And most importantly, wouldn't it be cool if they were cheaper too? That sounds like too much to ask. Unless you use today's sponsor, Blacksmith. These guys have solved the CI problem. You change one line in your GitHub action, now your builds cost 75% less money and happen 2 times faster. Oh, and if you're a Docker user, I know a couple of you guys like to use Docker, 40 times faster for your Docker builds because they cache them on NVMe drives that are actually attached to the machine doing your work. It's so much faster, it's hilarious. This was all enough for me to start using Blacksmith, but where it gets really cool is the observability bit. I can't believe GitHub hasn't fixed this yet. To be fair, GitHub Actions are all based on Azure, and Azure doesn't really have observability either. But man, once you have an actual search that works with filtering for the logs for every run of a given action, you can't go back. You even break down your Docker builds and see why they're slow and what layers are taking the most time to persist and go fix it. Adding Blacksmith will immediately make all of your builds in CI faster, but once you start looking at the dashboard, you'll find even more ways to make it more performant. At this point, I swear GitHub doesn't do this because they want to keep charging you for more build time. If GitHub made actions more observable, they would lose money because you would fix how slow they are. Or you can move to Blacksmith, where it's already going to be cheaper and faster, and then they'll hand you literal instructions on how to make your costs even lower. Yes, really. If it seems too good to be true, you should go try it yourself and see. Check them out now at soydev.link/blacksmith. This is going to be a fun one. We love you, TypeScript. For nearly 5 years now, Motion has operated in a large TypeScript monorepo. At its peak, it was roughly 2.5 million lines of code after excluding comments, node modules, etc. To manage this, we use Vercel's rather excellent Turbo Repo build system. Turbo Repo has its rough edges. I've been through it with that, but it is still the best option by far. It's so much better than the chaos we dealt with Lerna back in the day. Oh God, I'm having Lerna flashbacks after just saying that. Oh. By the way, if you're not familiar with Motion, they're a work management platform. Don't even know how to categorize them, but I've heard really good things. I know a lot of people who swear by them. It wasn't so AI before, but yeah, they're a way to manage the work that your employees are doing. It's kind of like a Jira type thing, but with a lot more layers to it. But that's what we're here to talk about. We're here to talk about them moving off of TypeScript. I have no intention to bash these guys in their engineering. It actually seems like they get what they're doing. Speaking of which, this is not a blog post hating on TypeScript. Quite the opposite. Motion would likely not have even survived until today without it. Motion has pivoted over 20 times. Oh boy. TypeScript lets us quickly validate ideas, and most importantly, it lets all of our developers operate in a truly full-stack manner. Very good call out here. The magic of TypeScript isn't just like, oh, it's JavaScript, but slightly more safe. It lets people who are working on one side of things work deeply on the other side as well, with a really good cohesive experience, especially when you build it up the right way. We could quickly and easily share code between front-end and back-end. We unified our development setup greatly. And of course, we took advantage of the extensive and lively ecosystem. Our front-end was written in React, mobile apps, React Native, desktop app, Electron. Infrastructure as code, believe it or not, TypeScript. Oh, they're on Pulumi. If you're not familiar, Pulumi is a TypeScript-based alternative for using things like Terraform. Yeah, if you're still managing your infra purely by clicking things in a dashboard, you're probably screwed. But all the infrastructure as code solutions they have their catches, but they end up being really worth it long term. I've personally not tried Pulumi much yet. It is really cool that you can configure everything as TypeScript files and a couple YAML pieces here and there. Seems really good overall. Haven't had a chance to really dive in though. Pretty cool that like they're all that deep on TypeScript, and they kind of went all in with it. As they say, we were, and we still are, huge TypeScript fans. But over time, things started to change. The dream of sharing code everywhere never really fully materialized. From the beginning, there were problems sharing code between React Native and the rest of the ecosystem. We had different versions of React and Tailwind from the rest of the web app, so many core libraries were simply never shared. Oh boy, we're touching on one of my favorite pieces to dive in on. I don't want to go too deep on this, but let's just make the web of all the things that they have TypeScript for. They have the React web app. They have the React Native mobile app. They have the Electron desktop app, the backend, APIs, and then the infra as code with Pulumi. So these are the pieces that they mentioned. It's very easy to assume, like if you were to like draw boxes of like where is the most code overlap happening, like obviously infra as code, this part's not going to share a whole lot with other things. Like what are even the type definitions of the Pulumi stuff going to do for you in your web app? They're not. There's like its own separate box that's pulled out somewhere else. So if we have everything else in this box, like how much code is actually being shared between these? Ideally, the type definitions from the backend and APIs are being exposed and used in these three services. You would assume that like there's enough different in the desktop app that there will be some difference, but obviously you're trying to share code between the desktop app and the web app. I'd go as far as to say that like the core UI experience should probably be the same repo for web app and desktop app. Not even same repo, but like same package JSON, same actual app. And then you have the React Native app. I find that there's this deep assumption from people that the point of React Native is so that you can write once and have the same app on native and on web. No. The catchphrase for React Native was never write once, run everywhere, which a lot of people assume it was. The goal of React Native was for Meta to make it easier for the full stack web focused people at the company to contribute small features to mobile. In particular, if I recall, it was the ads team at Meta that didn't write good native code, and the native engineers that worked on the mobile apps, in particular like Instagram, really wanted to make sure that external code contributions weren't crappy web views baked into the app. React Native was built out of love of the native platform, not hatred of it. The goal was to make it so that web devs could add native features to apps, not that you could write one code base and have it appear on every platform. React Native was built out of this deep love for the native platform, and it's not meant to just replace things the way that people seem to think it does. As such, React Native code should not have a lot of overlap with the React web code for the actual user interfaces that you're building. I've never been a big fan of all the tools that promise you just have this one package, this one project, this one package JSON, and it becomes your web app, your mobile app, your Android and iOS app, your desktop app, and all these other things, because these platforms are all really different. I have a video about this. Stop pretending mobile is the web. Really proud of this video. I'm surprised it didn't perform as well as I thought it did. I go really in depth on these ideas and how different mobile and web are and how we should stop pretending that they're the same thing, because they're not. You should be building these things differently. You should be treating them differently. You should be thinking about them fundamentally differently as you build. That doesn't mean you can't share some parts. Like when you build complex state management logic, when you have your API like hooks that you're hitting to get data, you can absolutely share pieces. But if we think of this a little bit differently, especially because they already have the monorepo, they have, we'll call this /app/web and /app/expo. The /expo version is obviously the mobile app, and /web is the website. These are two different folders in the project. And if you have pieces you want to reuse, like your API hooks, /utils/API, could have a package that includes all of the hooks that you're reusing between these two pieces. And if this is annoying to set up, which admittedly it absolutely can be, something I have done probably too often is I'll have a folder in each project, like /app/web/API utils, and I will just copy paste this folder between the two projects whenever I need to keep things in sync. It's nice to have this properly separated out as a package, But the point with this isn't that you're guaranteeing the exact same lines of code are being used across both, is that you're saving time and iteration bullshit when you're trying to make sure the behavior is the same across the platforms. Not the behavior when you navigate from one screen to another, but the behavior when you're fetching data from an API or you're doing some weird state management where you're trying to render the right things in the right place. Those types of things are where React Native gets really, really powerful. Not because you don't have to write the code for web or mobile, but because you can share the annoying logic bits between the two. You can share them as a package, you can share them by copy pasting, you can share them by vibe coding, pointing at the other folder in the monorepo. There's a lot of ways you can share that work. That doesn't have to be one project splitting out across many different things. And I find that a lot of people get really frustrated because they try to share their like divs with Tailwind stuff in them between the React Native app and the web app. No, you shouldn't be trying to share UI across these things. They're different platforms. You should treat them differently. If you try to make the mobile app use your web components or vice versa, you're in for a tough time. You should not be sharing components between these two pieces. You can absolutely share logic between them, but as soon as you try to share components between web and mobile, you end up with components that are worse for both. And this is such a common fail case I see people getting into. It's so common that we actually built Create T3 Turbo as a sample repo, somehow got like 5.6K stars, is almost entirely maintained by Julius, God bless. Create T3 Turbo is a mono repo that's goal is to show you how to host multiple apps with the same backend, taking advantage of Next.js, TRPC, Expo, Turbo, like good shared packaging between things. So here we have an API package that is shared for type definitions across web and mobile. Here you have a DB package that splits out all of the DB and ORM stuff so that it can be used across the auth package, the backend, and if you want to host a separate server, you can do that too. As you see, using TypeScript isn't, I'm using TypeScript because other decisions are hard. It's, I'm using TypeScript because I'm orchestrating a large build chain. That all said, you will start to run into problems, and that's what we're here to talk about. So knowing all of that, how did this go for them? Okay, we're still talking about code share. When we did manage to share code, developers would often forget mobile entirely when making changes to shared libraries, resulting in frequent "who broke the mobile app" hide-and-seek games. Again, as I said, there's no shame in copy-pasting a folder between the two when you want to make changes or copy things over. Forcing a shared package does not make anyone better. Eventually, we had to abandon React Native for certain screens where performance was critical. Interesting. This might be a fun read later. We thought React Native was the answer until our app hit 190% CPU. Calendar, for example, screen saw when they first launched. People did the number of bridges going between JS to native and back. Interesting. Because of all the back and forth for a calendar view, because there's so many layers rendering and then fetching data, this could be its own video. I would argue in a lot of ways they did make the right decision here, depending on how their API is structured. But the simple way of explaining this problem is when you're rendering nested things, and each of those nested things fetches its own data, the back and forth between React Native and native can get brutal. And I'm assuming they're not on the newest JSI bridge, which makes this even worse. So if you have the top level calendar component that fetches your calendar data, and then each of the events in the calendar needs to go fetch its own additional data. Once the first calendar JS code goes and fetches the data, tells native what to render next, then these new subcomponents render that all need their own data, and each of those has to go do another hop. Not great. This is why it's so valuable if you can move all of your data fetching up so that it happens once in the JS layer, whether you're building a web app or a mobile app. I've went in detail on this in a couple videos, like all the ways HTML gets to your browser. I go really in depth on this there, of the path that data takes through your applications when you design them. I think a lot about these problems. They're important. And it's interesting to see it as a CPU bottleneck on mobile, but it absolutely could be. And again, one of the cool things with React Native is that it is native. So if you have some views that benefit from native performance, or you just want to make it less likely you're having issues like this, it makes a ton of sense to move over to native for that. Because you can just call the native component from React Native. We're working on the T3 Chat mobile app, and I very much intend for us to work on some parts in pure native where it makes sense to. You'll be very surprised which parts it makes sense to. I do actually really like how they framed it at the end here, because again, these guys seem like really good engineers. Normally when I see these we moved off TypeScript posts or we moved off React Native, they're all cringe, but they're very good and thoughtful with this. Case in point here, going forward, we decide to do all new features on mobile with React Native first for iteration and speed. Then, based on the usage and performance demands, we convert them to native at our choosing. Round of applause for these guys. Seriously though, I wish people could both sides this well normally. It's such a relief to read articles from a team that sees the benefits and negatives of the different technologies they're using and is realistic about where to use each of them. It's so rare that this happens. Oh, I like these guys a lot. Back to the TypeScript article that we're all here for, though. Over time, we dealt with all the typical pain points of a growing TypeScript codebase. The language server frequently crashed, CI builds took forever, our somewhat optimized pipeline regularly would still take 20 plus minutes. A large portion of this will eventually be solved with the move to TypeScript Go, but this is the exact problem with TypeScript. There's a lot going on, and I have no doubt that eventually things will be great. But in the meantime, as a rapidly growing and scaling startup, we're not in control of our own destiny. Oh, this is a feeling I can very much sympathize with. I've basically set a hard rule for everything that we build with right now at Ping, T3 Tools Inc., the company building T3 Chat, Ping, Pickthing, all of that, where if we don't have confidence that we can meaningfully get in front of like the team making decisions and get changes in the direction they're moving to better align with what we need, then I'm very hesitant to work with them. Simply because if we're betting on their tech and it doesn't do what we need it to, we might just be screwed. And I hate that feeling more than anything. And I've been there too. And you might think like, oh, so you only use small startups, not big companies? Nope, absolutely not. There are tons of big companies that are very receptive to feedback and will actually make changes and move accordingly. And then there's lots of small companies that absolutely won't. I don't want to go in depth on them because those are bad experiences and I don't want to just sit here and complain about shitty companies. But I've had some like 5 to 10 person companies that were absolutely miserable to work with because they were convinced that that I was holding it wrong when they had global infrastructure outages that they didn't know about for 3 months that I found first. Ugh, I've been through it with some of these smaller companies and some of these bigger ones. Actually, on that note, it's funny, TypeScript's the topic here because I've had a really good experience with Microsoft overall. When I was a nobody back in like 2019 when I was at Twitch, we were running into some of these performance issues. And I reached out to Daniel Rosenwasser on Twitter when I had like 40 followers with a, hey, I work at Twitch. We're having some performance issues with TypeScript. Any advice? And they did a call with us when I was nobody. It was so cool. That was my first like, holy shit, I'm like able to make real change happen, not just at this company, but potentially impact the timelines for TypeScript. That was so cool. And Daniel stayed a good friend. We just finally hung out last week when I was in Seattle to visit Microsoft and hang with them a bunch. Great team. They really deeply care. And it's funny how much better, like just for a funny comparison's sake, I feel like I better understand Microsoft, their goals and their plans than I do Vercel right now. Size of company is not what determines this. That all said, TypeScript is inherently a slow-moving beast. They do everything piece by piece, and they make sure it's right before they make it the community's problem, which means it doesn't necessarily move at the speed we need to as a startup. If we're missing some piece that we need from other tools, like with Convex, I am confident that I can bug them and it will get fixed relatively quick. And if somehow it isn't, I can throw my engineers at the open source repo, get a PR up, and it's even more likely to get in fast instead. It's a huge difference that's worth considering. But I absolutely agree here and fully feel you with the sentiment that if your company is being held back by the tools and you can't get the tools to change, you're not in control of your own destiny. The company I would argue has done this the best is Meta. Meta made some not great tech choices early on, and they consistently come to the conclusion that it's easier for them to fix the tooling than to move off of the like bad code they have. They built a lot of the infra in PHP. PHP obviously didn't scale great for the size of Meta. So what did they do? They moved off PHP, right? No, they made their own language called Hack that compiles PHP into C++. I wish I was joking. It's actually really cool stuff. But that's what Meta does. It's easier for them to make a new language or rewrite the language than it is for them to rewrite the code base. Same reason they're doing all the cool stuff with the React compiler, because it's easier for them to have a compiler go through all of Meta's code and make it faster than it is for them to rewrite the code faster. Hermes is also a good example here where they're building a new set of tools for running your JavaScript code that are way faster with the goal of making it so you don't have to rewrite your native code, or even better with static Hermes, which will take your JavaScript and compile it to assembly. Static Hermes, it's going to be really cool. Not because you can compile your old React Native apps to it, but because a bunch of pieces of your app, like packages that you're using that could benefit a lot from that performance win, will have hopefully be built this way, and then you can pull them into your React Native apps and have insane performance. I'm genuinely really excited about what's going on there. That all said, if you're having problems building your TypeScript code base right now, if your team's complaining about their editors locking up constantly, you have to reload constantly, you are dealing with TypeScript server crashes, you're not getting a lot of the benefits that you normally get with TypeScript, and it feels awful. So I fully understand how you'd end up in this position. As they said here, we're waiting for the incredibly talented TypeScript compiler team to make fundamental changes. We're waiting for the really passionate Biome team to support certain features so that we can re-enable basic lint rules without making our CI times terrible. Yep. Yeah, no return on a wait is a really good rule that can absolutely fuck your times. Like, it's just any rule that requires like multiple layers, because this has to know it's an async function and that you're returning with a wait. That's just layers of JST for every single function in your code base that can get really slow, which is annoying. Biome could very well fix this, but Biome is still very early and funded by the community as a replacement for ESLint that's written with native tooling like Rust. Hopefully, it will get really good in the future. It's already surprisingly good, but it's not quite ready for a lot of these bigger code bases with strict rules. More fun ones. We had to wait for Zod 4 to come out just so that our monorepo would even compile, because with Zod v3, we were running into max recursion depth issues on the TypeScript compiler. For that matter, why do we need Zod at all? The ceremony's only required because TypeScript doesn't have runtime types in the first place. Nope. You need validators no matter what. There is no language that you don't need to validate your inputs on for API calls. This is the first thing I've disagreed with thus far. There is no language that properly, by default, sanitizes inputs that in a way that will keep you safe. You absolutely want a tool like Zod for validating. Otherwise, you're writing a shitload of validation code. Every language has solutions for this. You should use them in the other languages you're in. You absolutely do need Zod, though. If you're using Zod to just define function inputs that are not even leaving the same server, yeah, don't do that. Don't use Zod as a way to validate the inputs from one function to another function. Use Zod to validate inputs from one computer to another computer. If any traffic, any calling, any work is being transferred from one machine to another, you should have a validator making sure things are happening between them. And yes, there is Haskell, but we're talking about things that are actually running here, not things that are being posted on Twitter for points. I dearly love Haskell. It is not a relevant comparison because it's not a relevant language. So .NET is as much a framework as it is a language, to be fair. Like, this isn't a feature in the language, it's a feature in the framework, and you can absolutely have validators in your framework. Lots of things have that, but no language has it built in. Happy you guys feel me on the Haskell dunks. Oh boy, ORMs. The story doesn't get any better in the ORM side. As we found out the hard way, Prisma deletes the entire table if your where statement evaluates to undefined. We ran into many other bugs along the way. Drizzle seems better, and we sponsored them for many months, but it's not even 1.0 yet. Who's to say it won't also have bugs for the first couple years after launch? I am way too deep on this, and instead of just talking about it a bunch, I'm going to tell you everything they said here is right. Prisma's made a shitload of progress. Like, it's significantly better than it was. And funny enough, they got better by moving off of Rust into pure TypeScript, and it helped the performance a shitload. But I also love that they are sponsoring Drizzle because they want better options so badly. They haven't made the move, but they're sponsoring it because that's, like, long-term, an aspiration they have would be to use Drizzle for stuff. What's really funny as I read this is, like, every single point that they are making here is something that is actively being worked on, as they mentioned before. Like, we have here, the React Native stuff. There is so much work going into the JSI bridge for React Native, into things like server components to hoist as many of those calls up as possible so you don't have all the back and forth. Really good stuff there. With the TypeScript stuff, they even say, like, TypeScript Go is happening. Yeah, they're working on it. And then with the lint rules, we have Biome being worked on to make our linting way faster. With Zod v3, we had two different things that happened. First is Zod v4 fixes a lot of the performance issues. And then also, there was work done by a couple people, in particular, our friend from Archetype, David. Alex and I paid him to go deep on TRPC to find where the TypeScript, like, compiler performance issues were. He found some bugs in TypeScript directly, and then they got them fixed, which helped, like, up to 80% performance improvement for a bunch of applications that are building with a lot of these tools. To be clear, none of this is runtime performance. We have not talked about runtime performance at all here, other than with the React Native stuff. Everything else we're talking about here is just the performance of TypeScript in your editor, in your build tools, and all of those types of things. So we've had two huge wins with the Zod side. We had the TypeScript changes, which I would actually like to see how much better things are if they upgrade their TypeScript version, and also Zod v4 fixing a lot of performance issues as well. And then with Prisma, they are basically rewriting Prisma right now to solve as many of these problems as possible and to really work on closing issues because they felt so bad about how many issues just weren't being addressed. And we have Drizzle, which is a massive win on top of it. But as they said earlier, there's a lot going on, and I have no doubt that eventually things will be great. But in the meantime, as a rapidly growing and scaling startup, we're not in control of our destiny. That's the key. This stuff will get better, but they don't want to slow down the team and wait for the community to solve these problems. Oh no, we were doing so well, then somebody linked web components are the future from the same author. Rip. I'm going to ignore that because I like this a lot. Back to the article because this is really good stuff. The ecosystem is large, vibrant, and passionate. It's full of people who genuinely want the best for the web and are trying their best. But at the end of the day, as a CTO, I cannot rest the fate of my company in someone else's hands. The gnawing feeling of helplessness every time we ran into one of these issues was eating away at me, especially when these problems are for the most part solved in many mature ecosystems. It's no accident that Java and .NET rule the enterprise world. Runtime types are a given. Relatively fast compile times are mandatory for code bases that are millions of lines long. They both have an ORM that has matured over decades, which means that for basic CRUD operations, developers simply don't need to think at all. There's only one real choice. With multi-threading back on the table, we don't need to spin up complex workflow orchestration solutions to keep a single-threaded event loop free. And ultimately, this means developers can focus on solving novel problems instead of finding increasingly clever solutions for decades-old use cases. I half agree. You will find when you use these other solutions that you were in a bit of a grass is greener type thing. I'm not going to sit here and pretend that Java and .NET aren't meaningfully more boring than things are in the web dev world. I'm also a bit of a Java defender. I'm known for that. But it's particularly interesting they say this when Java's in the middle of its biggest upheaval of all time. They're rebuilding the primitive types in Java as we speak. Things like int and string are going to be different fundamentally at a base primitive level in the next major for the JVM. Java's changing so much right now that it's funny it comes up here because it's going to break all sorts of old code in all sorts of weird fucking ways. But you can also stay on an old version of Java and be fine. I would guess the average Java app is on some version of Java that's at least 6 years old. And while the ORMs are definitely way more mature, they're also going to be more limited and not have a lot of the niceties that we expect nowadays. Full stack type safety is going to be gone. You're going to be replacing a bunch of the code that you don't have to write because you're inferring types from back end to front end. Now you're going to have to write all of those type definitions and keep them in sync. If you thought it was bad making sure the same TypeScript package worked for the web and mobile apps, you have no idea how annoying it is making sure your types are syncing for different API calls across all of your services when you make one change in one function in one code base. And then keeping the deployments in sync and all of those other things, you're trading one problem for another. That said, if you have somebody at the company that knows the Java or the .NET ecosystem really well and can work through those problems, absolutely this could make a ton of sense. But you're trading one set for another. And I would argue there's an in-between not being explored here, which is writing TypeScript as though it is Java or .NET. Rethink how you're building that backend. Use simpler, dumber tools. Stub out basic REST endpoints. Use a really simple ORM. There's a lot of solutions and a lot of minimal structures you can build your TypeScript backends with. Also, the multi-threading thing here, yeah, you just said that this is for CRUD stuff, didn't you? Yeah. Basic CRUD operations, devs don't need to think at all. Then with multi-threading back on the table, we don't need complex workflow orchestration. You do understand that if you have a request that a user's making that takes a lot of time because it's waiting for an LLM to generate some response, and you have 4 to 8 threads open on this box, that thread is in almost all tools just sitting there waiting to complete. So even if you have multiple threads, you might not be using them all actively. And this is the benefit of the event loop in JavaScript. A lot of the workloads that we're doing, in particular, these types of CRUD things, actually perform better with an event loop than they would perform with traditional multi-threading. This obviously varies a ton across details of implementation and whatnot, but if you look at something like Rails, Rack is their solution, and each thread that Rack is working on is handling one request at a time. Is it boring? Yes. But solving CRUD operations at scale shouldn't be exciting. It should be boring and safe. It's 2025. We as an industry should know how to scale CRUD apps to hundreds of thousands of queries per second safely and reliably without bugs, without performance bottlenecks, and without excitement. Again, I don't think this is what the article was about. I really don't. Up until now, it was about the developer experience problems in the maintaining of the giant code base. I would argue there's roughly 3 types of scale. I've talked about this in other videos. They never perform, so I never know how to package them. But we have things like QPS on a given box. So this is like, if I have a server with 4 cores at 2 gigahertz and 4 gigs of RAM, how many queries per second can it handle? That's obviously something people like to talk about a lot and think about. I would argue most people think scale is just this, which is really, really stupid because that's the part of scale that matters the least. The two that matter a lot more are horizontal scaling, which is how well can this project be split up horizontally to handle larger amounts of traffic. You might be able to go longer without having 2 servers if your server can handle 100,000 QPS instead of 10,000. Once you hit 100,000 in one, you still need to split horizontally. How well does the tooling you're using handle that split? If it doesn't, you're screwed. If it does, awesome. And thankfully, TypeScript code base, especially if you're building them in the more serverless mindset, like if you're using Next.js the Next.js way, you horizontally scale incredibly well because you're not keeping any state on the server. The state's just in the database. And now your bottleneck is how well does your database connection layer scale instead. And then there is, I don't even know what to call it. I'll call it code base scaling. This is how well does your tooling handle more developers, more contributions, just more code moving around in the code base. What we've been talking about for this entire article has been code base scaling. How well do these tools handle when you have giant code bases with hundreds of engineers contributing hundreds of thousands of lines of code? Horizontal scaling is largely solved by most modern tools, especially those that are serverless capable. And then QPS doesn't really matter that much, especially now, because AI workloads are so much more expensive than the compute you'd be paying for the request. If JavaScript is 10 times slower than Rust, and you're hypothetically min-maxing perfectly, so you're using 10 times more compute than you would if you were using Rust instead, that would have been a 10x reduction in your AWS bill before. Now it's like a rounding error because the AI workloads that you're doing during those requests cost 1,000 times more than the actual compute for the request. 100,000 requests costs pennies. One LLM call can cost dollars. There's no, like QPS doesn't really matter as a scaling metric for a lot of businesses anymore. And I don't see any convincing argument that it does here. Whereas the horizontal scaling absolutely does, because when you max out your main box, can you spin up a secondary? How are you handling those types of things? With Vercel or Next or Cloudflare or any of these modern tools, you don't really have to worry about that anymore, which is awesome. But if you move to .NET or Java, you're taking over that problem again. Now you're building your own gateway to distribute the traffic across many different nodes. Now you're deep in Kubernetes or Pulumi or any of these things, trying to make sure your cloud infra and provisioning is ready for the different scales that you might hit. If you get a random traffic spike where suddenly you're getting 100 times your traffic, some number of those requests are going to time out and die as you're waiting for a server to spin up to handle it. All of those types of things become your problem when you move away from this nice little web dev world. They're trading issues here and here for issues here. And that's fine if that's the trade that they're willing to make and that they think is best for their business. There's no shame in that. But I dislike that they're calling out scale problems here and performance problems here when the only performance issue they had was React Native. And as we discussed earlier, they solved it the right way. Their backend isn't having performance scaling issues. The backend is having code base scaling issues. Apparently, the line in the sand for them was their agentic workflow system. We needed to have a code block that could execute arbitrary JS. And for obvious security reasons, that couldn't be executed in a backend container that also ran JavaScript. This coincided with a major, yet to be publicized, new initiative in the company. Sandboxing is hard no matter what you do. This requires a much deeper dive in like VM layering. I don't like this point either. It's really hard to sandbox safely. There's no reason a node server can't spin up another, like whatever you'd be doing in Java to handle this, you're spinning up a sandbox with JavaScript to run this code. You can do that in Node as well. Obviously, if you just call eval with a bunch of random user-driven code inside of your Next.js app connected to your server with Node in the backend, that doesn't work. But you can just call a bash command. You can just spin up some other instance the same way you can anywhere else. Or you can do what I would recommend, use any of the many different services to run that JavaScript in a safe sandbox in a server with infra that's built for this. I really don't like this point. It's a shame because up until now, I agreed with every fucking word of this article. But these two feel a bit cop-outy. I would love to talk more with them about what's going on with the executing of JS code bit. I am genuinely really curious. Back to the article, I have a feeling it's going to pick back up. Fingers crossed. So if we need to introduce another language for arbitrary code execution anyway, could we just start the new initiative in the new language? But that begged the question of which language. There's no reason that your arbitrary code execution backend needs to be a different language. You just need to isolate the sandbox right. 2 years ago, in a now infamous offsite in Chicago, we had a similar fork in the road moment. TypeScript does not and will never have a truly sound type system, and even back then we were having TypeScript fatigue. I wish we had more info on what this looked like. And while a majority of the backend devs wanted to move to a new language, the ensuing flame war between the language choices ultimately led to us remaining on TypeScript. This time, I've learned my lesson. No polls. Just kidding. In truth, I did discuss it with 6 or so engineers, but I didn't want to have a truly open forum. Yeah, as soon as you ask engineers what language do they want to use, and they're allowed to answer with languages they're not actually using much, it becomes a flame war because it's all idealism and not realism. You need to talk to people who are working in multiple languages to get a good taste of those things. The criteria was that I wanted a garbage collected, statically typed language that was performant and maximized productivity. Yep, that very much limits your choices. And according to the author, that meant C# and Java. Kotlin would like a word. Kotlin's a great language. Go would not work for this. They said statically typed. Go doesn't really understand types. Go barely has like nullish typing. If you have a function that can return null, it doesn't tell you that in the type layers at all. It's like really bad. That said, I have no beef with Java or C#. You guys probably hate Java more than I do, knowing my comment section. Anders is phenomenal at language design, and there's a reason he made both of these languages. They're very similar in their goals. In the end, they decided on C#, even though he had never used it professionally, because he genuinely believes Motion will be far more productive. Point 1 is the entity framework. As mentioned above, many of the frustratingly simple problems that we dealt with were the lack of a very robust and performant ORM. Most B2B software centers around basic CRUD operations, and we at Motion are no exception. After playing around with it myself, I was absolutely blown away by Entity Framework. At Motion, we long struggled with dealing with soft deletes, especially with nested models. With Entity Framework Core's global query filters, it's literally a single line of code. Interesting. So there's a global query filter that you can define that means anytime you try to query for that field or that model, it now will filter out based on that property. This is funny that like this is the callus they have. Note that at this point, you must manually set isDeleted in order to soft delete an entity. How else would you handle that? Okay, I live too deep in my TypeScript bubble if that has to be called out. They are really building this for like the dumbest, most obvious paths, which makes sense. This is going to be a very nice and boring code base. There are many more examples of really advanced use cases like table splitting, concurrency tokens, navigation properties. The thing that impressed me the most was how natural the change tracking was. Unlike in Prisma or Drizzle, where we had to plumb transactions through to every method in the repository layer, EF Core operated this way by default. Operations naturally just mutated the context, and saving the context would transactionally commit all changes. At any time, you can simply create a new context or save the old one. They should have evaluated effect. They would have had to learn more, and it would have had its own catches for sure. But effect handles a lot of those types of things really well. Entity instances became tracked when they are returned from a query executed against the database. Context.changeTracker.detect changes. They now have a layer where they can detect all changes and all things going through the ORM. That is really nice. You can build that yourself. I understand why they didn't, but you could. Having that built in gives you a lot more confidence, though. Like, they don't want to be sitting around building the tooling for these types of things when there's an ecosystem that has it all solved already for the scale they're at, especially because they're targeting these types of enterprises. Point 2 for why they picked C# is the similarity to TypeScript. I wonder why. These two languages were created by the same person. Oh, that might be why. It's only natural they look and feel similar. As many people are starting to realize, heck, Microsoft even advertises this. The language constructs are exceedingly similar. Both have async await, similar arrow patterns for anonymous function syntax, nullable types, and a lot more. Perhaps the best website comparing and contrasting the two languages is this one by our very own senior staff engineer, Charles Chen. The familiarity was quite important because it meant the velocity hit during the transition would be minimized. TypeScript is like C#. This is a whole website. This might be its own video, actually. It is funny how similar these look. I might have to do this in the future. Saved for later. Then we have the ecosystem. C# is the 5th most popular programming language, excluding SQL, HTML, and Bash. Are you saying that SQL, HTML, and Bash aren't programming languages? They're not. They're literally saying excluding, but I have to make the joke. While it is less popular than TS and JS, it doesn't necessarily mean that the size of the ecosystem will continue to benefit you. There's a certain minimum you have to hit. It's much more similar to logarithmic growth. After a certain point, it plateaus and there isn't more marginal utility to the extra library, especially when the quality of many of these libraries, quite frankly, isn't that high. In that sense, it's more of a binary test. Is the ecosystem large enough? Not is it the largest? I really like this point, actually. I find a lot of people are comparing things that are so close in quality, it barely matters anymore. What we need to be comparing, like, is it enough? And C# is absolutely a good enough ecosystem. For our use cases, it passed the test with flying colors. C# has a rich history of event sourcing, world-class support for the actor model, and really great message buses and more. Absolutely. How about AI coding, though? This will be fun. Apparently, the C# and .NET play really well with AI coding tools. In general, I found that the stronger the guardrails, the further the AI can go without human intervention. When I was playing around with F#, which had a much stricter compiler than JS and Python, I consistently found I could send Claude on longer and more complex tasks without oversight, and simply trust the compiler to catch the most common issues. The stronger the guardrails, the longer the AI can go. I think it's no surprise that Kotlin and Elixir, both very functional, consistently perform better with code generation. C# is top 5. Did not know that that was a thing. This is a podcast I'm very excited to watch later. Very excited to see how Elixir and Kotlin perform that well, especially because Elixir doesn't have the same level of strictness in the compiler. Strictness on the compiler aside, C# has hundreds of well-established and very performant lint rules thanks to the very well-documented Roslyn compiler API. One of those lint rules mandates that all public methods and fields have structured XML documentation around them, which is a well-known happy path for AI models. You know, everybody saying XML will make your prompting better? Now you can force XML in the actual pieces in your code base with C#. That's cool. Combined with the sheer volume of well-crafted examples throughout the .NET ecosystem, my very unscientific vibe-based finding is that AI models do indeed write better C# code than TypeScript code, given a similar amount of prompting effort. For backend, absolutely. Try to get it to write a UI in C# and you're fucked. Conclusion. .NET is not cool, and for good reason. For many years, it was Windows only and had a reputation of being quite archaic. As Google took Silicon Valley and the web by storm, technologies from Mountain View became the de facto standard. But .NET Core has been quietly and steadily evolving. This is most definitely not the C# of yore. It's modern, Linux first, and open source. It has blazing fast performance and a rock-solid, mature runtime. I recognize this is a contrarian take, but if you're the type of dev who has an open mind and prefers some against-the-grain type of thinking, then I think Motion is the right place. Apparently, others are making the same move. Here is TraceBait moving from TypeScript to C#. Fun. This was a phenomenal read. There were little bits I disagreed with. I think he went a little harder on the runtime performance than he should have, considering the workloads that were being discussed. But other than that, this was phenomenal. Thank you, Chandler, for writing this, and thank you to Motion for publishing your findings here. I wish more businesses would do this. It's a lot of work to write this type of thing, especially if you're going to write it this well, but it doesn't hurt your business at all. There is no negative to sharing this way of thinking. In fact, there's a huge positive. They're hiring. So if you're interested in a company that thinks through their engineering this well, I can't imagine Motion would be a bad place to work. Thank you all for taking the time. I hope you enjoyed this read as much as I did, and maybe, just maybe, you might end up moving off of TypeScript. Let me know what you think, and until next time, peace nerds.